episode. Today, we're diving into a topic that's on a lot of minds. If you're studying computer science engineering in 2026, what should you really focus on?
Yeah, and it's important to say right away, this isn't about hype or quick fixes. There's a lot of noise out there about AI replacing programmers or certain skills becoming obsolete. But that's not the full story.
Exactly. AI isn't making your degree irrelevant, it's making shallow learning irrelevant. So, what parts of CSE still matter deeply? What should you spend your time on? That's what we'll unpack.
So, first off, CSE is not just coding. Think of AI as intelligence, but CSE is the infrastructure that supports it. Without solid infrastructure, intelligence just collapses.
Right, and that's why many AI startups don't fail, because their models are bad, but because of scaling issues, poor backend architecture, concurrency bugs, or data bottlenecks. Those are classic CSE problems.
Which brings us to the core skills you need to master deeply, starting with data structures and algorithms, but not just for cracking coding interviews.
Yeah, it's about understanding complexity, graph algorithms, hashing, trees, and memory trade-offs. These concepts power search engines, recommendation systems, caching, all critical in real-world systems.
I can generate sorting code in seconds, but it can't reason about trade-offs under heavy load. That kind of judgment is still human territory.
Then there's system design, probably one of the most valuable skills today. Load balancing, microservices, distributed systems, caching strategies, fault tolerance, database sharding. These are the building blocks of scalable systems.
And industry interviews are really focusing on this now. It's not just about writing code, but designing systems that work reliably at scale.
Operating systems and concurrency come next. Understanding threads versus processes, synchronization, deadlocks, and parallel execution is key, especially since modern AI systems run many tasks in parallel.
Plus, cloud and deployment skills, Docker, Kubernetes basics, AWS or GCP fundamentals, CI/CD pipelines, and observability. If you can't deploy your code, it's incomplete.
And back-end engineering, APIs, databases, authentication, logging, monitoring. AI models live behind APIs, so this is crucial.
Now, what should you not over-invest time in? AI dominates repetitive, recall-based tasks. Memorizing syntax, writing boilerplate, manual CRUD scaffolding, basic debugging, or writing documentation from scratch.
So the rule of thumb, if it's repetitive and recall-based, AI does it better. If it requires judgment and reasoning, that's where you need to focus.
There's a real-world story that illustrates this. Many AI chat apps fail not because the AI model is weak, but because the backend can't handle concurrent users, crashes under load, or has unoptimized database queries.
Yeah, costs can skyrocket due to poor caching too. The model worked, but the system failed. That's why deep CSE knowledge matters more than ever.
For students wondering how to allocate their time, here's a weekly focus plan if you have about 20 hours. Spend 40% on fundamentals like DSA, OS, and networking, 30% on building system projects like a URL shortener or chat backend, 20% on modern AI awareness, and 10% exploring new tools.
To wrap up, CSE is not outdated. It's more important than ever. AI reduces effort but not responsibility. The less you think deeply, the more replaceable you become. The deeper you think, the more irreplaceable you become.
Well said. So focus on deep understanding and system thinking. That's your path forward in 2026 and beyond.